Hello students, today we're going to be talking about function notation, and it's actually in this Transformations of Functions foldable. So if you'll follow me there please. One of the questions I get a lot is, what is this f of x business? What's it mean? What's it for? And you've probably seen it in some other classes, and you've learned that it's basically the same thing as y. And that's true, but it's so much more. So before we talk about transformations, which is this inside part, you don't have to worry about this today. We're going to be reviewing function notation, all about it. Okay, so in addition to just being another name for y, it's a placeholder. Okay, so f of x is a placeholder for any function rule, meaning if I say, for instance, f of x equals 2x squared plus 3, okay, this is my function rule, and f of x is the name I've given it. So if I wanted to, instead of saying 2x squared plus 3 every time, I could just say f of x. And we can give it other names. We could call it g of x. We could call it h of x. There's just different, any letter you want to use, really. Once you have your function rule, there's all sorts of things you can do to it. And then we're going to be practicing some of those down here as concrete examples, which will make some more sense than this does at this point. So I have my rule f of x, whatever it is, maybe it's this one right here. I can take my function and I can multiply it by a number. I can add or subtract something from it. Or I can go through and multiply just the variable by a number, or add or subtract something from the variable itself. And here's what I mean. So you've probably seen this sort of thing before. If you just look at number 1 with me, it says if f of x equals x, then 2 times f of x equals blank. Okay, so we have our rule. Our rule is just x. So you could also write that as y equals x if you wanted to. Okay, f of x is the name we've given it. And x is our independent variable. So if I want to know what 2 times f of x means, I'm going to take f of x. Okay, so we know f of x is x. I'm going to go ahead and write x. That's my f of x. And then 2 times that is just, well, 2 times x is 2x. Example 2, if f of x equals the absolute value of x, then f of x plus 2 equals blank. Okay, so my rule is the absolute value of x, and the name I've given it is f of x. Okay, so if I want to know what's f of x plus 2, I'm going to take f of x, which in this case is the absolute value of x, like that. And then it's telling me to add 2 to the end, so bam, there it is. In a second, I'm going to have you try 2 problems that are kind of like these to see if you can do them yourself. And that will be part of your journal grade in this class. So make sure you give them your best effort. And then after the break, we will come back and look at example 3 and 4. Let's look at example 3. In this case, notice I've got f of x minus 1 right here. Okay, notice there's difference between these two. Here I've got something happening inside the parentheses. Up here was happening outside the parentheses. So that's kind of your difference here between your h and your k. So in this case, if f of x equals x squared plus x, then f of x minus 1 equals blank. I've got f of x minus 1. And notice that the parentheses have x minus 1 in them. So that means everywhere I see x in my rule, I want to replace with x minus 1. First thing I've got is x squared. And instead of x, I want to write x minus 1. So x minus 1, and you do need to put it in parentheses here because the square goes for that entire expression. And then plus x, so plus x minus 1. And here the parentheses don't matter so much because you're still using order of operations, but I'm just going to put it for clarity. And so that's your new rule. So here's where your x squared used to be. It's now x minus 1 squared to match this. And then plus x is your plus x minus 1. And let's look at example 4, and then you're going to try a couple more problems yourself. So if f of x equals 3 to the x power minus 1, then f of half of x plus 4 equals blank. Okay, so in this case, we've got our rule, 3 to the x power minus 1 exponential function. And we want to multiply the variable by 0.5 or by half, and then add 4 to the variable. Okay, so again, notice this is in parentheses. Anytime something is in parentheses like this in function notation, it's being done to the variable itself, not to the entire function as a whole. So everywhere you see your variable, in this case x, you'll have to do this, multiply and then add 4. Okay, so I'm going to start with 3, and it's to the x power, but I don't just want x anymore. I want half times x plus 4. So 0.5x plus 4. And you may want to put it in parentheses. Some calculators you're going to need to, some you won't. That's good to get into the habit. And then minus 1. So there was your 3 to the x, which is now 3 to the 0.5x plus 4, and then minus 1.